Okay, so today we are going to discuss, as we mentioned earlier, work energy power, some important questions from work energy and power. And I'm not going to discuss any theory part at the beginning. I think it is better we can discuss a related theory along with each question. So whenever we are discussing question, I'll explain what are the related theory about that particular question. So without making any delay, shall we start already now? Yeah. Okay. So let's go to the first question. Look, this is question number 1. You can check here. A block of mass m is kept on a platform which starts from rest with constant acceleration g/2 upwards as shown in figure. Work done by normal reaction on the block in time t's. Work done by normal reaction on the block in time t. My dear students, you can please note that this is 2019 main question. So it's JEE main question which is asked in 2019. I'll give you 2 minutes time. Can you check? Work done by the normal reaction. Work done by the normal reaction in time t. In time t. Try first. Work done by normal reaction. I think you're doing. May get the answer. We don't have time to wait. So can I go to the answer? Listen here. Work done by normal reaction. So here you can see that a block of mass m is kept on a platform which starts from rest. So the platform itself is moving with a constant acceleration g/2. So you can see that this is like it's not only a question from work energy and power. To answer this question, you should recall something which we learned in the chapter laws of motion also. Because see, normally on a surface, if there is a body, listen please, if you're keeping a body on a surface, it's if the mass of the body is m, you know that its weight is how much? Mg. And since the surface is horizontal, what will be the normal reaction? Normal reaction in this case, there is no other force. You can say normal reaction is mg. And if you're lifting this body to a height h, and if they're asking calculate the work done by the normal reaction, means you know the formula, work done is equal to force into displacement. So normal reaction is mg into h. That's a normal way of calculating the work done, you know that. But in this particular question, you can see that this block itself is going up with an acceleration g/2. My dear students, hope you remember the apparent weight of a body in a lift concept. If a body is accelerating upward, tell me what will happen to its weight. Will it increase or decrease? All of you, please comment. Yeah, some of you got the answer. Let me check whether that option is correct or not. So if a body is going up, what will happen? The weight will increase. And you know the formula for the reaction in that case, R is equal to, what is it? M into G plus A. This is the formula. Where is the acceleration? So here you can see what is the acceleration with which it is going up. It's g/2. Substituting m into g plus g/2. That is 3g/2. So m into 3g/2. This is the reaction. This is the force. We got it. Normal reaction is this much. Now they are asking work done. Work done to lift. Work done by normal reaction of block in time t. So we have to calculate, you know that for work done, it is force into height, displacement. So we have to find what is the displacement covered by the body in t seconds. For that, you can use equation of motion. Which equation? It is starting from rest now. So S is equal to, you know that ut plus half at squared. ut plus half at square. So since it is starting from rest, you can take u as 0. So S is the height, h is equal to half into what is acceleration? Acceleration is g/2 into what? T square. So look at the height, it is g t square by 4. This is the displacement. Now it's very simple. We got the force is 3 mg by 2 and displacement is gt square by 4. So what is the formula for work done? It is force into displacement. Work done is equal to, reaction is 3 mg by 2 into displacement is gt square by 4. My dear students, we got the answer. It is 3 into mg square t square by 8. Which option? Yeah, it's option B. Option B. How many of you got it? Yes. Arith, correct. Yeah, fine. Option B is the right answer. I hope it is clear for all of you. Please comment. Is it okay or not? I'm waiting for your response. So which is our right answer? It is option B. So this is the right answer for the question. Any doubt? So clear. Can I go to the next question? Yeah, thank you. So we are going to the next question number 2. Check this. A force acts on a 2 kilogram object so that its position is given as a function of time as x is equal to 3t square 5. What is the work done by this force in first 5 seconds? Work done. And once again, you can see this question is asked for 2019 JEE Main. Work done. Displacement is given x is equal to 3t square plus 5. What is the work done by this force in 5 seconds? Listen, first thing, you know that again they are asking what? Work done. What is the formula for work done? Work done, you know that work done is equal to F dot S. F dot S. But there is one more thing, you know that if the forces are variable, what formula will use? Work done by variable forces integral F dot dx. So here first we need to check whether the force is constant or not. Mass of the body is given, it's 2 kilograms. That's a constant. Now we need to check whether acceleration is a constant or not. If acceleration is also a constant, surely force is a constant. So let's check whether acceleration is constant or not. For that, you can take the displacement equation. X is equal to, check. So what is our formula? X is equal to, look at that, 3t square plus 5. This is the position of the body. Position. Rate of change of position will give you the velocity. So velocity v is equal to dx by dt. Dx by dt, which is equal to d by dt of 3t square plus 5. So you know that d by dt of 3 into d by dt of t square is 2t. So we get 60. 5 is a constant, so its derivative will be 0. So velocity is 60. I think that step is clear. Velocity of this body is 60. Now, we need acceleration. So we have to differentiate it once again. Acceleration is equal to dv by dt. That is d by dt of 60. 6 will come out. dt by dt is 1. So what is the answer? 6 meters per second square. 6 meters per second square. Now tell me acceleration is constant or not? Acceleration is constant or not here? It's constant. So acceleration is constant means we can easily go with the formula force into displacement. So what will be the force now? F is equal to ma. F is equal to ma. Mass is given as what? 2 kilogram. Acceleration is 6. So 12 Newton. 12 Newton. Now what they're asking, work done by the force in first 5 seconds. First 5 seconds, what will be the work done? For that, we have to find the displacement covered by the body in first 5 seconds. Displacement is given as a function of time. X is equal to 3t square plus 5. So can you do the rest? Find the displacement, multiply, and tell me the answer. Yeah, carry on. Yes, Aditya, I think it's the right answer. Others also can comment. Yes, Ashwat, right hand. Ashwat. Some are getting 960. 960 or 950? And 950, some 960 is not there in the option. As of course, Aditya, you can apply law of conservation of energy also. Any method you can use. Now, I'll tell you one of the mistake that you people are making. Those who got 960, the right answer is, I think it's 900. Okay, I'll tell you. We need displacement. Remember, students, this is the position. X is equal to 3t square plus 5. This is the position. So they're asking what is the work done first 5 seconds. First 5 seconds, that means we are starting from time is equal to 0. When time is equal to 0, we get x is equal to how many meter? 5 meter. This is the initial position of the body. When time is equal to 0, position is how many meter? 5 meter. You got it? Now we have to find the final position. Final position is after 5 seconds, you can substitute t as 5. So we get 3 into 5 square plus 5. So we get x2 as how much? 5 square is 25 into 3, 75 plus 5, 80. 80. Now, what is the displacement? Displacement is final position minus initial position, 80 minus 5. We get 75 meter is the displacement. Now, can you tell me what is the answer? Yeah. So work done is force into displacement, F into S, force is 12, displacement is 75. What is the answer? It is 900, right? Do you understand your mistake? Those who got 960, what happened to you? Is it clear or not? You have to learn from your mistake. Don't repeat it. Yeah, very good. Fine. Yeah. So the answer for this question is, you can see it is 900 joule. 900 joule. Okay. Can I go to the next question? Yes or no? Please comment. Yeah, thank you. Question number 3. Look at this. A uniform chain of length, length is actually, it is not Z, it is L only. Length L and mass M is lying on a smooth table, and 1/3 of its length is hanging vertically down over the edge of the table. If G is acceleration due to gravity, the work required to pull the hanging part onto the table is. It is a repeating type question. You can see questions based on this idea. Many times it has been repeated. So you can see the year which I put here. It is 1985. It doesn't mean that they asked only in 1985. This question came after that year many times, the same type. Okay, so yes, Suryanath, what is the doubt? Ask me, please. Where you took as 1. The last question, 1 second, all of you. Which one you are asking? Suryanath? Initial displacement is, I did not take 1, I took t as 0. Initial time means time as 0. So if time is equal to 0, we get 5 meter only. Got it. Is that clear or not? Yes, we are taking, it is starting from 5 meter. That's why initial part is 5 meter. Is when what is the meaning of initial? When time is equal to 0. So when time is equal to 0, what's the displacement? 5. And when time is equal to 5, it is reaching 80. So displacement is 5 to 80, 75. I think it's okay. I'm going to the next. Right. So here, what is the question? Yeah, I think most of you got the answer. I'll explain here. So a uniform chain of length L and mass M is lying on a smooth table, and 1/3 of its length is hanging vertically down. Let it be the table. And there is a chain. So I'm just showing the chain like this. 1/3 is hanging vertically down. 1/3. So what is the mass of the chain? It's M, and length of the chain is L. So surely what will be the mass of the hanging part of the chain? They're asking what is the work done to lift the hanging part. So what will be the mass of this hanging part? That's a question. Total masses, M, 1/3 of it is hanging means surely we can say the mass of that hanging part, this part will be M by 3. Yes or no? The mass of the hanging part is M by 3. Right. Now they are asking, leave the other part of the chain. We need only the work done to lift this part, lift that part. But there is a problem with this. You know that chain is not a point mass. It's like masses distributed over its length. If you are lifting a point mass from the ground to a height h, what is the work done for that? It is mgh. Yes or no? Work done to lift a point mass to a height hs, mgh. But this is not a point mass, you know that. So in such a case, there is a simple method. I think we have to use which concept? Can anybody tell me which idea we can use from it? Yes, Anish, very good. Others also? We can use the idea of center of mass. This is a uniform chain. So uniform chain means you can assume the entire mass of this hanging part is concentrated at its middle. That means you can assume that this entire chain is concentrated at this point. So you can treat it as a point mass of mass how much? M by 3. It is located here. Is that idea clear for you? Yes. Now, if it's a point mass means to lift it, we need to move it through how much distance from here to here only. That is the displacement. That is the displacement. So we need to find that displacement. You know that this is 1/3 of the chain means total length of the chain is L. So the total length of this hanging part will be L by 3, which means this is half of that. That means what is the height to be lifted? It will be half of L by 3, that's L by 6. So H is equal to what? L by 6. Is that idea clear or not? Yeah. Now it's easy. Mass is M by 3. Now we can use the basic formula only. Work done is equal to what? mgh. mgh, substitute M by 3 G into H is L by 6. Look at that. It is mgl by 3 into 6. It is 18. mgl by 18. Option D, I think. Yeah, Srinigesh. Many of you got the right answer. Clear or not? Answer is mgl by 18. Yes, I will explain how L by 6 comes. Do you understand the idea of center of mass? Center of mass is here, right? Middle. So instead of considering this entire part of the chain, you can consider it as just like a point mass. Point mass located here. That means what is the height? This much. From here to here, this is 1/3 of the length of the chain. So what is length? L by 3. So this distance is half of that. L by 3 by 2. That is L by 6. Clear now, Suryanath? Yeah. Right. So these type of question comes, you'll do it. Confident or not? All of you. Can I go to the next? Yeah. Thank you. Question number 4. Listen. When a rubber band is touched by a distance x, it exerts a restoring force of magnitude F is equal to ax plus bx square, where a and b are constants. The work done in stretching the unstretched rubber band by L is 2014 question. Direct only. This question, or Aditya, this one or the previous one? Here, whenever they are asking work done, you don't need to bother about the sign of it. That we need to check work done by whom. Who is doing work, then only we can say the sign of the work. You got it? For example, if work you are lifting a body means work done by us will be positive and work done by the gravitational force will be negative. Okay, come to this. This is a direct question only. Can you try? 1 minute. Force is given F is equal to ax plus bx square. You can easily see that force is a function of position. That means it's a variable force. So in the case of variable force, you know that how to calculate the work done. We have to use the method of integration. Do it quickly. And it is, you can see the work done in stretching the unstretched rubber band. Unstretched. So starting from unstretched position means initial lower limit you can take as 0. Okay, upper limit only we have to calculate by L. So upper limit is L. Anish, I'll check. All of you can comment. Yeah, Aditya also got the same answer. Yes, I'm going to the answer. What is the formula for work done by a variable force? It is integral f dx. Limit, you know that starting limit is 0, upper limit is L. We need to stretch it to a distance L. Integral f dx, substitute for f. What is f? Integral ax plus bx square into dx. So you can see that there are two terms. So we need to split. So first term will be integral ax dx plus integral bx square dx. A is a constant, will come out integral x dx. B will come out integral x square dx. What is integral x dx? You know that integral x dx, basic formula is integral x raised to n dx is x raised to n plus 1 by n plus 1. If you're using that result here, integral x dx is x square by 2 plus b into what? X cube by 3. Is this step clear or not? What are the limits of integration? 0 to L. Lower limit is 0, so no need to put only upper limit. You can substitute, you'll get the answer. W is equal to A, X, you can give L square by 2 plus B, L cube by 3. A, L square by 2 plus B, L cube by 3. Which is the right option? It's option C. Option C. Is it okay or not? Clear? Please comment. Yes. So I'll be going to the next question number 5. Question number 5. Force F is equal to minus K into Y I cap plus X J cap, where K is a positive constant, acts on a particle moving in XY plane starting from the origin. The particle is taken, it's not 1 second, particle is taken along the positive x-axis to the point A0 and then parallel to the y-axis to the point A, A. The total work done by the force F on the particle is. This question is asked for the first time in 1998. Okay, so do you understand the question here? There is a force, you can see it is minus K into Y I cap plus X J cap. So clearly you can understand it's a function of Y coordinate and X coordinate. They are changing. All right. Acts on a particle moving in XY plane, starting from the origin. So where is the body? The body is in the XY plane. So let us take such a plane. I'm just taking this as Y axis. This is the X axis. So XY plane means like this. And we are starting from where? From the origin. So this is the starting point, origin. And first, you can read the question carefully. The particle is taken along the positive x-axis to a point A0. So first, the body is being moved along the positive x-axis to the point A, 0. So x coordinate is A and y coordinate is 0. And after that, then parallel to y-axis to the point AA. Parallel to y-axis means from here it is moving in this way to the point what? A, A. What is the work done for this process? That's a question. So there are two methods to do it. One is, I'll tell you, that is an easy method, I think. And I will explain the other method as well. And you can decide which one is easy for you. Listen, first, I'm starting with the force. forces F is equal to, check, force is given as minus K y I cap plus x j cap. All right. You know the formula for work done, it is F dot displacement. So displacement, since it is moving in xy plane, displacement means the position of the body keep on changing. So I'm just taking this as dr. So dr, I'm writing it as, you know what is the standard form of position vector? R is equal to xi plus yj. That's the standard form. So here we are taking a small position vector only. So we can write it as dxi cap plus dy j cap. Is that step clear? I'm just taking a displacement vector there. Clear or not? This step? Come in, please. Arith, actually the formula for work when we need F dot displacement. The displacement equation is normally, if you're representing it's like this, it will be xi plus yj plus zk. This is a standard form of displacement vector or a position vector, isn't it? Yeah. So here we need a small, why we are taking a small distance? Because the force is a function. I mean, force is a function of x and y. So it keep on changing. So we can't directly take the total displacement and total work. We can't calculate. Again, we have to use the method of integration only. So we are taking a small position vector, that is dxi cap plus dyj cap. Is that clear? Okay, thank you. So now work done is equal to dw is equal to F dot dr. Integration we can do after some time. F dot dr. Okay, substitute. F is minus k into y I cap plus x j cap dot dr is dx I cap plus dy j cap. Okay, hope you remember dot product. How to find dot product of two vectors if they are giving in vector form? It is x1, x2 plus y1, y2 plus z1, z2. Yes or no? So in that form, if you are writing, what will be the first term? Minus k, I'm keeping it here. Y I cap dot dx I cap. I dot I is 1. So we get the first term as y dx. Yes or no? First term will be y dx. What will be the second term in the same way? Anyway, I dot j will be 0. J dot I will be again 0. X j cap dot dy j cap. J dot j is 1. So second term will be what? X dy. Is it clear or not? Yeah. Heiza, correct. So minus k into y dx plus x dy. Y dx plus x dy. What is it actually? This one, you can write it as minus k into derivative of xy. This is like x is a function, y is a function. So hope you remember product rule in differentiation. If there are two function comes, the derivative is first function into derivative of the second. That means derivative of xy will be x into derivative of y dy plus second function y into derivative of x. Is that clear? This step is okay or not? Derivative of two function comes like this, means first function is x into derivative of second dy plus second function is y into derivative of first dx. So the same thing only you can see x dy plus y dx. So that is equal to derivative of xy. So that's what I written here. This is dw, right? dw. Okay, what we need work done. So how can we calculate work done? Work done is equal to integral of this. So integral dw is equal to minus k will come out into integral of derivative of xy. What is integral dw? Integral of dw is w only. Now dot product is already taken. Suryanath. Okay, so here after that, yeah, we are using product rule in differentiation here. Right. So integral dw is W is equal to minus K into what is integral of derivative of xy? All of you comment. Integral of derivative of xy. It is xy only, right? Very good. Integral of derivative of xy is xy. Now you can apply the limits. What are the limits? 0 to a, because starting point is 0, ending point is a. 0 to a. So what will be the result? Apply the limit for both x and y. So x you are putting upper limit, it will be a. Y you are putting upper limit, it will also be a. A into a will be what? A square. So the result will be W is equal to minus K a square. This is the answer for the question. Minus K a square. Why there are 2a comes means there are two functions. For both the functions you have to apply the limit. Okay. Shruti, how that 2 comes? There is no scope of 2. We are just applying the limit. Upper limit minus smaller limit. Upper limit will be a only. So a into a. For both the functions you have to give upper limit. Minus lower limit, both are 0, no? So a square minus 0. So we get minus K a square. Is this method okay? Right. Now I'll tell you the other method also to calculate the same result, and you can think which is easy. So final answer is minus K a square. Option C is the right answer for us. Second method, listen all of you please. Look, I'm just in the question, it is given that initially Aditya, the problem is force is not a constant. It keep on changing. It may work in this particular question, but the method you have to follow this way. Got it? Listen here. Second method I will be explaining. If it is not fully clear, I'll be explaining it in the class. Why you are not able to do in that way in all the cases. Come back. Second method, they are asking work done to move first in this way, then in this way. Okay, so I'm taking this work done as W1 and this work done as what? W2. So surely the total work done will be W1 plus W2. Yes or no? Now, how to calculate W1? You can see W1, what is the path? The path is along x-axis. Along x-axis, what is y-coordinate? Along x-axis, what is the y-coordinate? 0. So if you are substituting y-coordinate as 0, tell me what will be the force? If y-coordinate is 0, the force will be only minus k x j cap, isn't it? If y-coordinate is 0, force is equal to minus k x j cap. Is that clear? If y-coordinate is 0. J cap means what is the direction of that force? J cap indicate direction of forces along y-axis. So forces along y-axis, displacement is along x-axis. Tell me what is the angle between force and displacement? 90. If theta is 90, what will be the work done? Work done will be 0, no? So we can say W1 value is equal to how much? 0. Is that step clear? W1 is equal to 0. Now we need to calculate W2. W2. Listen, when for W2, what is x coordinate? X coordinate is A. But y coordinate is changing. Y coordinate is changing to what? A. So x coordinate is A means you can write the formula F is equal to. For W2, I'm writing F is equal to x coordinate is A means we get minus K, minus K into y coordinate, I'm keeping y into what? I cap plus a j cap. Is that clear? Because along this direction, you can see x coordinate is A only. So for x, I'm putting what? A. So I get a j cap. Got it. And what is the direction of the displacement in this case? Displacement is along this way. This force has two components. Look at this. One is this component. What is the direction of this component? There is I cap. I cap means it is along x-axis now. Along x-axis. So this component of force is acting along x-axis, but my dear students, the displacement is along y-axis. What is the angle between these two? Zero, no? I mean, angle is 90, work done will be zero. So work done by this component is not doing any work. That is zero. But this component, it is along J only. Along J means what's the direction? Upward. Okay, so who is doing the work here? Work is done by this force only. Which force? F is equal to minus K, A J cap only doing the work. Got it or not? So what is the magnitude of that force if you're taking? It is minus K into A. This is the magnitude of force. Minus K, A. And what about the displacement? Displacement is from here to here. Tell me, what is that height? How much? A. So force is minus Ka into displacement is again A. What is the result? Minus K, A square. So this is the W2 value. W1 is 0. So W2 is minus K A square. It means total work done will be minus K A square. Clear or not? So which method is easy? First or second? Okay, it's up to you. You can use whatever you want. So the answer is minus K A square. Yeah, second is easy to understand. Like there is no confusion of integration and differentiation in the second case. Just logic you can apply and you'll get the answer. Can I go to the next question? Can I go to question number 6? Thank you. Look at this. A light inextensible string that goes over a smooth fixed pulley as shown in the figure connects two blocks of masses 0.36 kilogram and 0.72 kilogram. Taking G is equal to 10 meter per second square, find the work done in joule by the string on the block of mass 0.36 kilogram during the first second after the system is released from rest. No, like Sahil, you can do the first method in any case. If you are fully okay with the integration differentiation, then it is, I'll suggest first one only. Because a time consumption, I mean, first one you can easily do it. You can save time. Okay, that we'll discuss later. Look at this one, right? This is 2009 question, an important this type. You can see many questions of this type. And once again, it's not only like you cannot solve this question only by studying the concept from work, energy, and power. Many other ideas has been used. Do you remember such an arrangement? Which chapter? Laws of motion chapter, we studied about connected motion thing. Remember or not? Yeah. So this is the same kind of situation. So let me name this mass as M1 and this as M2. M1 and M2. Yeah, vertical motion. Here you can see first mass is 0.36 and other is 0.72. So second is exactly the double of the first. Yes or no? Which means in calculation, to make it simple, can we take a M1? If you're taking M1 as M, what is M2 value? It is 2M, double. Yes or no? That M value we can substitute at the end. Now analyze the question. My dear students, what we have to find. Please check what we have to calculate. Find the work done. Find the work done by the string. String is doing how much work by the string on the block of mass 0.36. Remember, this is the 0.36 kilogram mass. On that string, during the first second, time is given in first second, 1 second, how much work is being done by this string on this one. So string is doing the work means, what is the force? Can you tell me which is the force? String is pulling means what is the force within a string? Very good. Tension. So who is doing work here? It is a tension. So in the diagram, I'm just marking tension here, T. So tension is a constant, you know that in a string, in this motion, tension is a constant. So work done by constant force only. So first thing we need to calculate tension. Then we need displacement. How can you calculate displacement? Time is given. Displacement you can calculate if you know the acceleration because it is initially starting from rest. So my dear students, we need to find two things here. One is tension in the string. Number two is what? Displacement. For displacement, we need acceleration. So let me begin with the tension first. Do you remember the tension formula? Tension in a string formula in this connected motion. T is equal to loss of motion. We studied it in detail. This is the equation. Tension T is equal to 2m1 m2 into G divided by m1 plus m2. Remember it or not? Yes. So I'm just substituting the values here. 2 into what is m1? M1 is m. What is m2? 2m into G divided by m1 plus m2. M plus 2m, 3m we will get. So we can cancel. So 2m1 into m2. Yeah. What is the answer? 4 mg by 3. Is it the tension? Is this step clear or not? Yeah. So this is the tension means this is our force. So we got force part. Force part is clear. Now what we need? Acceleration. Then only we can find displacement. Acceleration formula again for connected motion. You know that it is m1 minus m2 into G by m1 plus m2. Substitute. M1 is m. So here m1 you have to take the bigger mass. Heavier mass is 2m. So we can take it as 2m minus m by 3m into what? G. So we get G by 3. This is acceleration. This step is also clear, I think. Aditya, okay, I'll check. A equal to G by 3. Now, how can you find the height displacement? S is equal to ut plus half at square we can use. U is 0. First term is cancelled. Half into acceleration is G by 3. Time is 1 second. So 1 square is 1 only. What is the displacement? G by 6. G by 6. Right. We got everything. Force is 4 by 3 mg and displacement is G by 6. So I'm going to calculate the work done. Work done is F into S. Force is 4 by 3 mg into displacement is G by 6. Calculation part you have to do. Mass is how much? 0. What is the mass? 0.36. Yeah. 0.36. 10 by 6. Please calculate and tell me the answer. Aditya, very good. Right answer. Yeah. Others also. Quick. Anish, I think there is a calculation mistake. Please check it again. Yeah, more the right answer. See, negation. You'll get a perfect number only. See, 0.36 into 100 is what? 36. So it is 4 into 36 by 3 into 6 now. So 24 by 3. Answer is 8 joule. What is the confusion here? Yeah. Okay or not? Yes. You have to practice this type of question. Okay, if you're doing 2 or 3 times, then any question of these type, if they're asking, you will be able to do. So this is the way, like if you're practicing like this, you can easily crack. Can I go to the next? Yeah, thank you. Question number 7. Look at this. A block, you have to read this question very carefully. It looked like a complicated one, but it's not. like that. It's very easy. Listen, please. A block B. So in this diagram, you can see the block B is attached to two unstructured springs. They're springs S1 and S2 with spring constants K and 4K. So spring constant of, remember, S1 is K. That means the right side spring is K and S2 is 4K respectively. The other ends are attached to two supports M1 and M2, not attached to the walls. So please note that this M1 and M2, this M1 and this M2, they are not attached to the wall. Okay. The springs and the supports have negligible mass also. So no need to worry about the mass of the spring and mass of the supports. They are negligible. M1 is negligible mass, M2 is also negligible. Okay. And there is no friction anywhere, neglect friction. All right. Now what they're asking, the block B displaced towards the wall by a small distance x. You can see this is the initial position of the wall B. It is displaced through a distance what? X and released. The block returns and moves a maximum distance y towards the wall 2. So from here it is moving towards the wall by a distance y. The displacement x and y are measured with respect to the equilibrium position. So equilibrium position means initial position. This is the initial position. So from here the block B is moving through a distance y. The ratio y by x is, this is a question, the ratio y by x. It is an easy question, students. Why it is easy means, you just listen, please. Listen here. You can see that when this block is displaced through a distance x, since this is not attached to the wall and it is massless, means along with this movement, this spring and this mass, everything will move without any kind of stretching because this end is free to move. Do you understand? This has no mass. If there is some mass, means we can say the spring S2 will also be stretched. But that is a light spring. There is, the mass is negligible. What will happen if the block B is moving toward left? This spring S2 and the block M2, everything will move along with it without stretching it. Is that idea clear or not? Yes. But it is given that it is moved through a distance x. That means this string will be compressed by a distance x. Yes or no? This S1 will be compressed. If it is compressed by a distance x, in that some restoring force will be there. Mainly an energy will be stored. Tell me, what is the energy stored in this spring if it is compressed through a distance x? What is the formula for energy stored in a spring? Tell me. All of you. Yeah, it is half kx square. So for the spring S1, spring constant is given as k. So energy is stored in spring S1. I am writing it as U1. U1 is equal to half kx square, right? Half kx square. Right. Now, after that, we are releasing it. Now, be careful. When we are releasing the system, this block B will come back to its initial position. That means the spring S1 will be coming back to its normal unstructured position, isn't it? Normal unstructured position means what will be its energy when it is coming back to the unstructured position, all of you? Zero. But you know that according to the law of conservation of energy, that spring S1 has already have some energy, it will be transferred to the other spring. That means as a result, what will happen to it? When it is moving through X, my dear students, this block M2 will also move towards X. That means when B reaches back to the equilibrium position, M2 will be reaching to the block. That means it cannot move further. So again, since the energy is transferred, what happened? Due to the effect of that energy, this S2 will be compressed. It is given that it is compressed through a distance, how much? Y. So energy of the S1 spring is transferred to the energy of S2. It is given that there is no other force, no friction, nothing. So entire energy will be transferred. Tell me, what is the energy stored in the second spring if it is displaced through a distance y? U2, we can write. What is its spring constant? It's 4K, no? So what we can write? Half spring constant is 4K y square. Energy is conserved. Equate them, you'll get the answer. Concept is clear or not? Idea is okay or not? So in this question, the idea we are using is law of conservation of energy. Yes, it is because there is no loss of energy. There is no loss of energy, Arith. There is loss of energy if there is friction or something. So here, Shruti, listen, if the first spring is compressed through a distance x, half kx square energy will be stored in it. And it is released, and that energy is transferred to the second spring. And it is given that the second spring is moved through, or this body is moved through a distance y. That means the spring will be compressed through a distance y. So the energy stored in that one is half. Again, formula is half kx square only. But for the second spring, the spring constant is 4k, displacement is y. So half 4k y square. Equate these two, you will get, they're asking the value of what? Y by x. Tell me the answer, all of you. Just equate. Many terms will be cancelled. Ashwat. Yeah, Aditya, right answer. Sahil, right answer. Ashwat, don't make calculation mistake, man. See, U1 is equal to U2. So half kx square is equal to half into 4ky square. So half got cancelled, k got cancelled. X square is equal to 4y square, so x is equal to 2y. Remember, they're asking y by x. Y by x will be 1 by 2. 1 by 2 is the right answer. Yeah. Option C. Aditya, see, first we are displacing the body block B through X. At that time, what do you think? Will there be any energy in S2? S2 will move freely. It won't be structured because of mass. M2 is negligible mass. So it is moved through a distance x, means the energy stored in it will be half kx square. That part is okay now? Yeah. Now we are releasing it. After releasing it, what happened? This will come back to this equilibrium position initially. When it is coming back, what will be the energy of S1? S1 will become 0. That part is also okay now? Yes. It is coming back means what is the displacement from the mean position? Half kx square is energy, no? At mean position, what is it? Yeah, right. So at mean position, the energy will be 0. But when the block B reaches here, you can see that M2 will be moving the same distance. So now M2 is in contact with the wall. Now it cannot go further. But since the energy is transferred to S2, what happens? S2 will be compressed. I think the idea is clear now. Yes or no? Yeah. Okay. Can I go to the next question? All of you comment. Yeah. Fine. So next is question number 8. It's an easy question. A body is moved along a straight line by a machine delivering constant power. Constant power. The distance moved by the body in time t is proportional to. Power is constant. Then displacement is, or distance is proportional to. This I can do quickly. Power is equal to a constant. So power, I am writing it as a constant K. K. What is the formula for power? Power is work by time. So work by time is equal to a constant K. Work is equal to K into T. There are many methods to do it. So I'm using work energy theorem concept. Work done is equal to what? Change in kinetic energy. So I'm writing half mv square is equal to K into T. So they are asking only proportionality relation. Proportionality relation means I can write V square is proportional to T. That means V is equal to square root of T. Square root of T means T raised to half. Okay. And V is equal to dx by dt. So dx by dt is equal to, I'm just writing equal to only T raised to half. So dx is equal to T raised to half into dt. They're asking displacement, so just integrate it. Integral dx is equal to integral t raised to half dt. So integral dx is x is equal to t raised to half dt means t raised to n plus 1 by n plus 1. So t raised to half plus 1 by half plus 1. That means t raised to half plus 1 is 3 by 2. That's it. So displacement is proportional to t raised to 3 by 2. Option C is the right answer. Yeah. So the right answer. Yeah. Okay or not? Clear? Please comment. It is an easy question, but this question also came many times. Next. Time is almost over. We can discuss one more question, and after that, we'll wind up today's session. Can I go to the next? Yeah. Look at this. A point particle of mass m moves along the uniformly rough track PQR as shown in the figure. The coefficient of friction between the particle and the rough track equals mu. The particle is released from rest from the point P and it comes to rest at a point R. The energies lost by the ball over the part PQ and QR of the track are equal to each other, and no energy is lost when the particle changes direction from PO to QR, PQ to QR. The values of the coefficient of friction and the distance x is equal to QR are respectively close to. Lengthy question, right? So this is, you can see, 2016 main question. First, understand what they are asking. We need to find two things. What are the two things? One is coefficient of friction value, mu. And the other one is distance. Which distance? Distance QR. Distance QR means, see, this distance only we have to calculate. And for that, what are the ideas given? Look, the particle released from rest from the point P. From here only, the particle is released. The energy is lost by the ball over the parts PQ. So when it moves along this surface, it will lose some energy. Why there is loss of energy? Because there is friction. So some energy will be lost to do work against friction. And from here to here also, some energy will be lost. And it is given that the energy lost by the ball over the parts PQ and QR of the track are equal. So energy loss for the part PQ is equal to energy loss for the part QR. So remember, in both the case, like from P to Q and Q to R, the energy is lost by doing work against friction. So I'll be writing it here. Listen, work done against friction for the path PQ is equal to work done against the friction for the path QR. This is one given information. Is that idea clear? The formula which I wrote, is it okay or not? Yeah, right. Now, work done for PQ. Be very careful. See, I'm not using any idea which you don't know. Everything is concept which we studied in our class only, but it's how you are applying it in a particular situation. So here, how can you find work done? Work done is force into displacement. Displacement is this height, the length from P to Q, that will calculate data. Force is which force? Tell me, which force is acting here from P to Q? It is friction only. So to calculate the work done, we should have an idea about friction. What is friction formula? Friction is F is equal to mu N. You know that force of friction is equal to mu into normal reaction, coefficient of friction into normal reaction. So how to find mu only? They're asking. One question is, what is mu value? That we'll get it. Normal reaction. How do we find normal reaction? For that, what is the mass of the body? M. So let me take the mass here. So at that point, you know that weight will be acting vertically down. It is mg. Mg. Normal reaction means reaction normal to the surface. So this is a normal reaction. So how can we find the value of N? This angle is 30. Then this angle will be 60. This angle will be again what? 30. So you can resolve this mg, you'll get mg cos theta. So from this diagram, you can easily understand what is n value. Tell me, students, it is mg cos theta. Is that clear? Normal reaction for this point is equal to what? Mg cos theta. Okay or not? Yeah. So frictional force, I can write here, F is equal to mu into mg cos, angle is given as 30. So mg cos 30. That is a force. Now displacement. Displacement is, look, we need distance from P to Q. That also we can easily find. I'll show you how. PQ. This is a right angle triangle. From this, what is sine 30? Angle is given as 30. Sine 30 is opposite side. What is opposite side? 2. It is given as 2 meters by this distance PQ that I'm taking as a x. X. So sine 30 is 1 by 2. So we get x is equal to 4. So what is the displacement in that case? It is 4 meters. 4 meters. So we got the displacement is equal to 4 meters. Now you can substitute. Look at this. Work done for PQ only I'm writing. It is force. Force is how much? Mu mg cos 30. Cos 30 is a force into displacement is 4. This is the work done for PQ. Is it okay? That step. This step is okay or not? Comment, please. Yeah. Now it is equal to work done for from where to where? Q to R. Q to R, we don't know the distance. They're asking that distance also in this question. So we can take that distance as, I'm just taking the distance as X. So again, there will be friction, but the advantage over there is it is a horizontal surface. So if M is the mass, the weight will be mg. Normal reaction will also be what? Mg only. Mg. So what will be the force of friction in that case? Mu n, mu mg. So I'm writing work done. Force of friction is mu mg. No need of substituting cos theta. Mu mg. Mu mg only. And what is the displacement taken? X. So it is mu mg into what? X. So look at LHS is mu mg cos 30 into 4. RHS is mu mg into X. Okay or not? Now it's your turn. Can you solve this and find the value of X? X quickly. Mu mg will be cancelled on both sides. No, Hisa. Cos 30 is root 3 by 2, no? Approximate answer is enough. Yeah. 2 root 3 will come. Yes. 2 root 3 means 3.5. Yes. Correct, Aditya. 2 root 3. Very good. X is equal to 2 root 3. 2 root 3. Root 3 is 1.71 into 2, almost 3.5. They are not asking the close to only. So no need to get the exact number. Close result is 3.5. So X value we got no 3.5. Is that clear? X is equal to 3.5. That part is clear. Can I go to the next? Next, because we need mu also. Here the problem is there are 2 options with 3.5. So we can't stop here. We have to find mu value as well. Okay. So how to find mu value? That also I'll show you here. Listen. So I think this part is very clear for all of you. We got X value as 3.5. How to find mu value? You can use law of conservation of energy, because initially, where is the body? Initially, the body is at the point P. At that point, what type of energy the body possesses? It is kept at a height h. Which energy? Potential energy only. Potential energy. But as it moves down, it is doing some work, and it reaches here, it stopped. Stopped means what is the final energy? 0. The final energy is 0, which means all the energy initially the body had is lost by doing work. That means this work we are taking as W1 and this work we are taking W2. This W1 and W2, if you're adding, that will be equal to the initial energy of the body. So what we can write is, in the next step, Initial energy is what? mgh. Mgh is equal to work done for PQ plus work done for QR. Work done for PQ and work done for QR formula already we calculated it. So just substitute it. What is H value? H is 2 meter. So I'm writing here mg into 2 is equal to mu mg cos theta into 4. We already calculated it, plus mu mg into x, but x we got it as 3.5 or 2 root 3. 2 root 3 I'm writing here. Mg will be cancelled in all the terms. Mg cancelled, mg cancelled, mg cancelled. So we get 2 is equal to mu cos 30 into 4 plus mu g is cancelled, mu into 2 root 3. Now it's your turn. Can you calculate mu value from this? You can take mu out from these two. Cos 30 is root 3 by 2 again. Uh, 2 into mu into cos 30 is root 3 by 2. Root 3 by 2 and 2 will be plus 2 root 3 mu. So 2 root 3 mu, 2 into 2 root 3 mu, right? Mu is equal to 1 by 2 root 3, isn't it? Yeah, correct. Mu is equal to 1 by 2 root 3. What is the close result? 0.2 something will be there, no? You check. Yeah, I think 0.28 something will come, Aditya. So it will be 0.29 will be the answer. Yeah, option C is the right answer. 0.28 something will come. So it is option C. Yeah. Anyway, you can, if you did not get, you can try it at home, like you can practice again. Clear or not? Concept is okay or not? Please comment. Okay, so I'm going to wind up today's session. If we could discuss only 9 questions, but it's enough. It's just a beginning only. So I just want to check, was it helpful? Like the session was okay or not? So we'll be continuing. Okay, so please practice these questions, these type of questions. If you need, I can send the slide or the worksheet. I'll be sending. Okay, so thank you. We'll be continuing with the remaining question in the next session. Bye. Take care.